from the assumed inequality, it follows that there exists some stopping time sigma less than or equal t, of course, such that the arbitrage, sorry, I didn't write that, the arbitrage-free price of the option is strictly less than the expected value of the option, what's the word? Discounted option at time sigma. So we construct the following, let me write that properly, strategy. First, at initial time 0. Buy the option C at its initial price, which is given by pi AC. We sell t plus 1, with t the terminal time, claims with payoff the option, the value of the option at time t, multiplied by the indicator that sigma is equal to t for any t in our time interval. So the total invested amount is the expectation under Q, summing over all of these claims, minus the initial value of the option. We could rewrite that, of course, as the discounted value of C at time sigma. That's because this indicator gives us that every other goes to 0, minus this initial price, which is greater than 0 by assumption. And thirdly, we invest this amount into the risk-free asset B. All that remains to be done is at the terminal time capital T, we gain this positive difference multiplied by the value of the risk-free asset at time capital T, which is, by assumption, greater than 0, risk-free. That is, with probability 1, we don't lose any money. So this is an arbitrage opportunity. Unsurprisingly, part B is very similar. The strategy this time is at time 0 to sell the option at its price at that time. We have from the proposition in the lecture notes, which is for me proposition 5.18, a hedging strategy. Phi, with initial price the same as the American option, and terminal value greater or equal the terminal value of the American option. And as a third step, we put the difference of this initial price and the expected value of the American option at the time sigma, which just by the same logic exists as stopping time by assumption, for which this difference is positive. We put this positive value into the risky asset. Then at terminal time, capital T, once again, we gain the value of the risk-free asset multiplied by the difference. Of course, now it's the negative difference from the previous part A, but that's because we've assumed essentially the other way around, which is again greater than 0, risk-free. And so we have another arbitrage opportunity.